less than, which is what operation? Subtraction, okay? So fewer than is representing subtraction. And I don't know how you learned it in Algebra 1, but I always told my Algebra 1 students, taught them this yesterday actually, less than or more than or fewer than is always flip-flopping your numbers and variables to the opposite side of that symbol. So if it's 7 fewer than a number t, it is not 7 minus t. It's 7 fewer than t. So it's basically saying here's t, take away 7, right? So you have to flip-flop where these are, t and then 7. So you would get the expression t minus 7, okay? Now, I don't want to confuse you and have you doing it flip-flopped all the time. It's only when it's a fewer than, less than, more than, when there's that than word in there, that's when it flips. Otherwise, it's pretty much in the order you see it, okay? All right, what would you do with this? 2 times the sum of A and B. Right, so the sum of A and B means you're adding A and B, but you have to put that in parentheses, okay? So it's 2 times the sum of A and B, okay? So A and B times A and B added together times 2, okay? 2 times the sum of A and B. Pretty good on that? Okay, quick run through. Sum, addition, difference, subtraction, right? The difference of whatever and whatever, yeah, it's subtraction. Quotient, division. Product, multiplication, times, multiplication. I think that's about it. If you come across one you're not sure about, ask. Okay, example 2. This one says, you're on a bike trip. You traveled 52 miles the first day. 52 miles on the first day. Okay. Since then, your average rate has been 12 miles per hour. I want to know the algebraic expression for your distance. Okay, what's the algebraic expression for your distance? So it says 52 miles on the first day, and then an average rate of 12 miles per hour. How would you write that as an expression for how far you've traveled? So you're on a bike trip. You went 52 miles the first day. Since then, your average rate has been 12 miles per hour. What is an algebraic expression for the distance you've traveled? Yeah. I love mistakes. Don't be afraid to make a mistake. What do you think it is? It's okay to be wrong. Okay. Piper. A variable. What variable do you want to use? What are we talking about? It's miles per hour, right? So however many hours you're going, 12 miles per hour. So we would say if h is the number of hours since the first day, then our expression would be 52 plus 12 times however many hours we've ridden, okay? So this would be your algebraic expression. that make sense? So 52 is constant. We know that we did 52 miles the first day. We're trying to figure out the distance we've gone based on however many hours past that we've ridden. Okay? Questions on that? Okay, so they're going to ask you to evaluate some of these expressions, which just means take a number and plug it in, right? Evaluate just means you're plugging in whatever number you're going to use in place of the variable. So here's where PEMDAS is going to really come into play. Do you remember PEMDAS?
Yes.
Parentheses, exponent, multiply, divide, add, subtract. Remember, multiply and divide goes left to right, and add, subtract goes left to right. Okay? Keep that straight. So this is going to say evaluate. And for this first one, it's 7 times a plus 4 plus 3b minus 8. And they're going to say for the values, a equals -4 and b equals 5. Okay, so like I said, you're just plugging in numbers for the variable. So if a is -4, you're going to put a -4 here. B is 5, you're going to put a 5 there. And then just be real careful with your PEMDAS. It's probably been a while since you've really had to think through the order of operations. So this is going to be 7 times -4 plus 4 plus 3 times, that's your 5, right? Plugging in a 5 there, minus 8. What do you do first? The parentheses. So in your parentheses right now, -4 plus 4 is 0. So you're saying 7 times 0 plus, I always kind of do it as I go. You're welcome to lay it out as the whole thing right now, 3 times 5 minus 8. But because I took care of my parentheses already and there are no exponents, multiplication would come next, right? And we can just multiply this then. So 3 times 5 is 15 minus 8. What's 7 times 0? 0. So this goes away. So really it's just 15 minus 8, which is 7. Okay, so when you evaluate, you should get 7. Pretty crazy. It's good stuff, right? All right, do this one. X over 2 plus y squared. For for x equals 1 and y equals a half. Okay, so if we're going to evaluate, we're going to substitute numbers for variables. What's this first one going to be? 1/2, right? 1 over 2, 1/2, plus, what's 1/2 squared? 1/4. You got to square the top and the bottom, right? 1/2 squared. So that's the first thing you're going to do is the exponent, because we don't have parentheses with any operations inside of them. So 1/2 squared is 1/4. So you have 1/2 plus 1/4. What do you have to make sure of when you add fractions? Common denominator. So 1/2 plus 1/4 is really 2/4 plus 1/4. So your answer is what? 3/4. What? Okay, questions on that? Okay. We are skipping example 4 in the book. Moving into a couple definitions. Again, you have learned these before, so this should just be review, so I'm going to move fairly quickly through them. If I lose you at some point, just ask me to slow down. All right, first definition is a term, okay? When we talk term, we're talking a number, a variable, or the product of both. What is product? Right. So if I say like 6x. That is a term, right? Or 6zp. That is a term. You can multiply numbers and variables, or you can have a number by itself or a variable by itself. That is a term. What's a coefficient? The number in front of the variable. If you want the math lingo, the math language for that, a coefficient is the numerical factor of a term. Yeah, fancy, but essentially it's the number that comes right before the variable, right? Okay, then we have a constant. Do you know what the constant is? Jesus is constant. He is good. How about mathematically? What's the constant? It stays the same, right? It is constant. So there is no variable attached to it because a variable is always changing, right? You could plug in different numbers for a variable. A constant has no variable because it cannot change. It is constant, okay? So a constant is a term with no variable. Okay, so let's say we have this expression, negative 4ax plus 7w minus 6. Tell me your terms. How many terms, first of all? There are 3 terms here, okay? So this is a term, this is a term, and this is a term. Okay, so those are all terms. Okay, how about coefficients? Can you tell me a coefficient? Negative 4 is a coefficient, and 7 is a coefficient. Okay, so it's the number that comes before the variables. And then a constant, the negative 6, right? And it is a negative 6 because it's minus 6, so it's essentially saying plus a negative 6 would be the same thing. So that is your constant. Okay, coefficient are those 2. Questions on that? Yes. Okay, one more definition, and then we're going to do a little bit of work with, yeah.
So,
Negative 6 is a constant. That's this one here. I changed my colors. I should have made this purple and this purple, right? But the constant is this one. Color coding, sorry. Yes. I know, I'm sorry. I'm sorry. I actually have talked about you several times today because I told my geometry classes if ever I'm using colors that you can't see, like one of my friends last year who was colorblind, I was talking about you. Yeah, for all kinds. Yes, yes, yeah. Anyway, okay. Last definition here is like terms, and I guarantee you've heard that phrase before, right? Like terms have to have the same variables raised to the same powers. Okay, so for instance, if I were to give you, what's a power, by the way? The exponent. So if I give you this, 3x squared plus 5x squared plus 9y cubed z plus 2yz minus 4y cubed z. Okay? In that, your like terms would be these two, because they both have the x squared, right? And then a different set of like terms would be which ones? 9y cubed z and negative 4y cubed z, okay? So this one with this one, okay? Those are like terms. Any questions on that? Is this all coming back? Okay. Couple examples. So you are going to simplify a bunch today. Simplify just means put it in the simplest form that you can get it to. So don't oversimplify where you're trying to simplify things that can't actually be joined together, right? It has to be like terms that you simplify, but you will simplify. All right, so here's your first problem. 7x squared and z. Put the bar in the z. That's why I always put a bar in my z, because it looks too much like a 2. Okay, 7x squared plus 3y squared plus 2y squared minus 4x squared. Okay. Now, I am not super picky that you rearrange your setup so that your like terms are by each other, but you're welcome to do that if you want. If you're going to rearrange, make sure the symbol that's before the number stays with that number, right? So if I'm going to rearrange this so my like terms are next to each other, I would write it 7x squared minus 4x squared plus 3y squared plus 2y squared. Like I said, you don't have to do that step. I'm okay if you skip that step. If you can just do it in your head with simplifying on a very basic one like this, that's fine, okay? How do I simplify that? What does it become? 3x squared, right? So this is 3x squared. It's not to distinguish. Purple's fine right now. I just switched it to switch it. Plus what? 5y squared. Add those together. So 3 plus 2 is 5, but the y squared stays. Notice this is not 3x to the 4th, right? It's like saying 7 apples minus 4 apples is still apples, okay? You don't want to change your exponents when you're adding things together. Good on that? Okay, so your answer here, simplified, would be 3x squared plus 5y squared. Second one. Here's where we're going to start seeing a few mistakes. Okay. Help me simplify that. What do you get first? Negative 3k minus m, right? This is essentially a negative 1 that you're distributing to both of those. So negative 3k minus m. Please don't forget about that negative out in front, because that's where the mistakes get made. And then you would distribute this 2k and then minus 8m. Okay, so now combine like terms. Negative 3k, is it plus or minus 2k? It's plus, right? This minus right here, that guy is not going with our k's. That is part of the m, okay? So 3k, negative 3k, plus 2k is what? Negative 1k, or you can just call it negative k. You don't even need the 1. What's your next term going to be? Minus 9m. So this is negative m, negative 8m. So negative m minus 8m is a negative or minus 9m. And that's as simple as you can go because you can't combine a k and an m. Okay? Questions on that? And like I said, you don't need the 1. You can leave the 1 off if you want. All right, last one. Negative 8a minus 3b plus 10 times 5a minus b. Couldn't tell if my handwriting, if that was a B or a 6. It's a B. All right, simplify that. Step 1 here. What's it going to become? Right, so negative 8a, and then this is minus a negative, which always becomes plus a positive, so plus 3b, plus what? 50a, distribute this, and then what? Negative 10b, so minus 10b. Okay, so then from there, combine your like terms. You have a's and you have b's. Right, so negative 8a plus 50a is 42a. And then what? Minus 7b. 3b minus 10b, so negative 7b. And that would be your answer. Está bien? Sí. All right, you have 10 minutes. Get your homework done.